Hello and welcome to our celebration of the Kubernetes 6th birthday and Kubernetes and the community. So first of all, my name is Joe Beda. If I didn't already get an intro here, I'm a principal engineer here at VMware working on Tanzu, pulling together a lot of our Kubernetes story and products across the company. And I was also one of the founders of Kubernetes back when I was at Google. And what we want to do here today is talk about a little bit of the history and opportunities around Kubernetes, why we're still excited about it, and how we see VMware playing into it as Kubernetes continues to move forward. So first of all, happy birthday to Kubernetes. It was 6 years ago that we announced the open source release of Kubernetes. It was pretty raw at that time. It's come a long, long way since then. And it's just been awesome to actually see the community come together and form around it, and the amount of, uptake that we've seen across the industry. It's really something that has taken me by surprise and has been super, super humbling. Now, Kubernetes started with a single commit. And I actually had the honor of actually having my name on that first commit for Kubernetes. But the reality is that it actually started before that. There were a lot of folks working to pull it into shape. And I really just took the sort of bookkeeping task of creating a new repo, checking things in, and making sure that we were ready for open source. But I think, it's important to recognize that even then, Kubernetes was not the work of a single person. It was the work of a lot of folks putting it together, and it was work of a history both at Google and beyond with projects like Borg, but then also drawing from a lot of experience from the high performance computing and grid computing world to really bring all of this stuff together. And so, there's definitely a sort of standing on the shoulders of giants going on here, but also recognizing that, there's a community that pulls all of this stuff together. And it's really ignited this ecosystem in the cloud native world that I like to call beautiful chaos. As engineers, we like to think that, hey, everything is ordered and designed, but the reality is a lot messier than that. Everything we do, is part technical and part human. And one of the things that I really prize about the Kubernetes community is that there's so much room for people to do interesting things. There's so much room for people to bring their creativity. And one of the beautiful things about the Kubernetes world is that there really are no gatekeepers. This is an open world where folks can use the ideas, the patterns, the code. It's both open source, but also an open community in terms of people being able to bring their ideas, work on top of Kubernetes, extend it, without having to get approval from anybody. And that's super exciting to me. So I think, looking at some numbers, Kubernetes itself, there's a lot of big numbers here, 2,500 contributors, 90,000 plus commits, a lot of folks running this stuff in production, a lot of this stuff running a lot of this in production, and a lot of folks really using Kubernetes to the fullest in terms of giving self-service access so that developers can get their job done without having to wait on their IT organization. And that self-service access, I think, is a huge piece of what makes cloud native tick, in my mind. Now, this is another aspect of beautiful chaos. For those who haven't seen it, this is the Cloud Native Computing Foundation landscape. And this is essentially logos from all the different companies and projects that play a part of the cloud native world. And couple of things. Number one is that I'm sure this is an incomplete list. I'm sure there's a lot of stuff that's missing from this. And the second thing is that, I'm one of the folks who got this stuff started, and I can guarantee you that I don't know about most of the things that are on this particular slide. It's really, both inspiring and scary to actually see a slide like this. And so I think the key here is that there's so much potential here. And this is what I mean by beautiful chaos, is that this is greater than any single company could actually achieve. And it really, goes to show that no matter how smart the people inside your company are, how smart any single company is, the community as a whole has more smart people than you have in your company. And I think this really just goes to show that. So I think this is really, really exciting to see so much brain power, so much passion, so much creativity being channeled and brought together inside of this large growing ecosystem. Now, the hard part is that, like, you know, I have a full-time job keeping up with this stuff, and I can't keep up with everything that's going on here. And I think this is part of the challenge that we have, is that this is so active. There's so much flexibility. There's so much excitement that, like, literally nobody can keep on top of all of this. And it's honestly overwhelming. And so we've seen the early adopters of Kubernetes and cloud native be super successful by going deep, understanding this world, carefully choosing the tools and putting them together so that they can get the best output from it, and really supercharge their org with all the tools that really, you know, are included here. But not everybody has the skills, the time, the resources to be able to pull together a team of experts to really take the best advantage of the cloud native ecosystem. And that's really where VMware and VMware Tanzu come into play. Our goal is to take that entire ecosystem, boil it down so that you can go ahead and get started. One of the sayings that I like to say here is that constraints drive efficiency. This applies at multiple points of the spectrum. If you want to implement Kubernetes and you start from open source and you start from the community stuff, you can do it, but you're going to spend a lot of time, a lot of effort trying to take all of those things and boil that down into something that you and your organization can make the best use of. I think similarly, we find something happens to application teams. When you give application teams too wide open a set of choices, there's an analysis paralysis that sets in that really sort of prevents you from concentrating on the things that are going to be most applicable to your problem. Now, so what we want to do with Tanzu now is actually make sure that we can help narrow those choices, get you started, get you on that cloud native journey without you having to understand everything that's happening in that slide. On the same token, we don't want to cut you off from that community. That is a powerful, powerful thing that as you face unique problems, as you want to start specializing and going deeper in parts of the cloud native ecosystem, we want to make sure that you can get the best of both worlds. A way to get started quickly, but access to that deep, growing, vibrant, beautiful chaos that is the cloud native ecosystem as a whole. And so really the way that we're looking at this is that we want to empower our customers through VMware Tanzu and the portfolio of products and services we have there to bring together the new patterns that we're seeing with cloud native, including that self-service that really is, you know, one of the big benefits of cloud and cloud native. Really empower new personas, new roles, new ways for people to do things, new ways to break problems down so that you can build expertise. And we want to supercharge all of that with new tools. Our job is not to provide the exact answer for everybody. We hope that we can get you started on this journey in an effective way. But ultimately, our job is to provide power tools so that you can actually get started, understand this world, and then be able to apply it to your problems in your organization to be as effective as quickly as possible. Now, how are we doing this? Let's break down how we're actually approaching this. So the first thing we want to do is we want to do right by customers. And this is what I've been talking about a lot. We want to simplify adoption. We want to make sure that you can get started, you can realize these benefits without having to become experts in everything that's happening in the cloud native ecosystem. The next thing we want to do is embrace the community. Again, we want to help you get started, but we don't want to cut you off from the rest of that larger community. And we do this by really investing in open source, investing in upstream, building in the open, and making sure that we're good citizens of this large and growing ecosystem. So this is not just a VMware Tanzu world. This is a larger cloud native world that we want to be ambassadors, your ambassador into that larger world. And then finally, we want to do right by the artists. Constraints build efficiency, but those constraints should be a matter of policy, a matter of choice, not a matter of capability. Sometimes you need to color outside the line. Sometimes you need to do something special. And that really means being able to extend the platform yourself or adopt some of the tools from that community or from the set of vendors out there. And this is really about, you know, having VMware and Tanzu be your introduction, your guide, your bedrock as you approach this thriving, exciting, chaotic, and sometimes scary ecosystem that is cloud native. All right, so we got a great set of talks here for you today that we've pulled together. Starting out, we had Jared Rossoff. So he is one of the product managers leading up the effort to integrate Kubernetes into vSphere with Project Pacific. And so he's been on that project for a long time. That team is so excited to get vSphere 7 out, get Pacific and the fusion of Kubernetes and vSphere into your hands. And he's going to be talking through that. The next one is Erin Munsell. So I worked with Erin at Heptio, brought her on board, and she has done an awesome job helping to outline and guide our efforts for how we manage Kubernetes at scale. And when we say at scale, we don't mean just number of nodes. What we mean is the number of teams, the number of sites, just that clear, proliferation. As folks start seeing success here, they start seeing a lot of success, and that ends up being something that you have to wrap your arms around with. And Erin's going to be talking about Tanzu Mission Control in that case. And then Bosky joins us from Pivotal. And she's going to be working to talk about how we're taking all of the deep expertise that we have in making modern platforms available to development teams through things like Cloud Foundry and Pivotal Application Service, now renamed the Tanzu Application Service, and talk about how we're adapting and really, bringing all of that expertise, all of that knowledge onto Kubernetes so that you get the platform that really lets you play a part of that large ecosystem, but then also a really streamlined, effective, and efficient way to get your development teams up and running and effective. So really great set of folks that are going to be talking to you today, and I hope that you learn a lot. And once again, happy birthday to Kubernetes. Thank you so much.
Hi, my name's Jared, and I'm a product manager on vSphere. And I've been leading the Project Pacific, or the vSphere with Kubernetes effort, for the past 3 years. Now, Joe talked about a lot of awesome stuff. I think Kubernetes has been a huge influence on the vSphere team. And what I'd like to talk to you about today is, first of all, how we've been taking that core Kubernetes architecture and how it's actually transforming the vSphere platform itself. I'm also going to talk about how we're able to take vSphere and have vSphere transform Kubernetes, really make it easy to use and adopt for every data center administrator out there in the world. So with that, I'm going to start off with a brief introduction of what we've actually done in vSphere with Kubernetes so that you understand architecturally what's going on under the covers. For those of you that aren't familiar with vSphere, this is kind of what it looks like today. You've got vCenter, which is our central management and control plane, and then vCenter manages clusters of ESXi instances. ESXi is, of course, our hypervisor software, which is runs virtual machines. And so what vSphere does is sort of pools all these resources together and gives operations teams all kinds of advanced tools for managing their data center and all of the workloads running in their data center. So when Kubernetes came around, we saw an opportunity to kind of transform this architecture and the approach to which we build new features and services inside of vSphere. And so the first step of this was we actually embedded a Kubernetes control plane right into vSphere. So we now run Kubernetes control plane nodes inside this cluster of ESX hosts, and we run what we call a spherelet on each of the ESX hosts. Now the spherelet is a port of the Kubernetes kubelet to ESXi. ESXi, if you're not that familiar with it, it's an operating system in and of itself. Most of what it does is run virtual machines, but the spherelet actually runs natively on the ESX operating system itself. So now we've got this cluster of ESX hosts, it does all the same functions as an existing vSphere cluster, but we've got this Kubernetes control plane that we can use to control and orchestrate all the workloads on it. So one of the next things we did was we added to ESX the ability to run container workloads. So normally you think of a hypervisor as a thing that just runs virtual machines. And what we did with Kubernetes is we added a runtime on ESX that allows me to run a Kubernetes pod isolated in its own virtual machine. Now, this is a hyper-optimized VM. It boots in hundreds of milliseconds, much faster than a general virtual machine guest. And it's super optimized just to run containers. You don't have to provide an operating system image or a VM configuration or anything like that. You just provide a Kubernetes pod spec, and it launches it in its own virtual machine. Now, what's interesting about this is from a performance perspective, this Kubernetes pod running in this lightweight VM has its own dedicated Linux kernel and its own dedicated virtual hardware. And so it doesn't suffer from any of the noisy neighbor problems that often happen with a traditional Kubernetes software running on Linux. It's also ultra secure. If I have a container breakout, now what's going to happen is that container is still isolated in its own virtual machine boundary. So a breakout is contained just as it would be as if it was running in a virtual machine. Now, what I'm left with is this really interesting cluster that combines two really important technologies. We've got this Kubernetes control plane, we've got the ability to run Kubernetes pods and containerized workloads, but we also have the ability to run VM workloads on this same pool of server resources. So despite the fact that we're using Kubernetes in here, I wouldn't really call this cluster a Kubernetes cluster. It has a lot of aspects of a Kubernetes cluster, but it's still a vSphere cluster. And, as a DevOps user consuming this, I'm not really deploying a containerized workload here. Think of this more like your cloud platform. This is something like an availability zone in a public cloud. And so when I interact with this, I don't necessarily interact with standard Kubernetes objects. What we've done in vSphere is we've added a set of services that provide new CRDs and operators that expose cloud-like concepts through that Kubernetes API master to your DevOps teams. So this includes things like Tanzu Kubernetes Grid that lets me manage Tanzu Kubernetes Grid clusters, the vSphere pod service, which gives me access to that pod runtime on the hypervisor. I also have CRDs and operators for managing virtual networks, persistent storage, and even container registries. There's a bunch more services that are going to come in the future, but this is what's in the box today. And so this is what we mean when we talk about vSphere with Kubernetes. It's this underlying cloud platform reimagined with the combination of the vSphere hypervisor together with a Kubernetes control plane. And it presents a system that is super compelling for DevOps users to use and very easy for existing vSphere admins to actually deploy and manage. So with that, let's actually jump over to the product and give you a sense of what it feels like to use this thing. So here I'm looking at vSphere. This is the vCenter UI, and this is commonly the UI that a data center admin would be using to manage their data center. And if you look at the way this is organized, I've got my inventory tree over on the left. Here I have my vCenter. Underneath my vCenter, I can have multiple virtual data centers. Within virtual data centers, I can have clusters. These are the clusters of ESX hosts. And up until this point, this is all standard vSphere for anybody that's used versions before vSphere 7. But what's new here is namespaces. And so when you look at these namespaces right in this inventory view, these are those Kubernetes namespaces in that underlying Kubernetes control plane. And so namespaces become a new unit of management inside the vCenter UI. And this allows me to group together all of the logical components of a single application into a single namespace. So to get an idea of how we actually work with these things, why don't we go create a new namespace and see what that's like. So here I'm looking at my namespace list. I can say, hey, let's create a new namespace. We'll call it Kubernetes birthday. Now I have to pick which cluster it's going to get created on. I'm going to pick my cluster. And there, I've got a new namespace. Now, this did a lot more than just add a namespace to that underlying Kubernetes cluster. In addition to interacting with the Kubernetes control plane, we're also controlling a lot of components of vSphere itself. So we also created a DRS resource pool for this namespace, and we created an NSX virtual network for this namespace. We also have the ability to tie identity and access control to this namespace and storage policies and things like this. So let's continue with looking at some of these things. So for example, permissions. Like I can control which DevOps users in my enterprise are allowed to access this namespace. This federates with my identity infrastructure, so I can go in and pick an Active Directory user, and I'm going to give myself edit access to this new namespace I created. I can also manage storage, right? So vSphere has data stores and storage policy-based management. And so what I can do is I can go in and look at those storage policies that I've already defined in my vSphere environment and just choose which ones do I want to allow this namespace to use. So let's pick this Kate's policy. We'll add it to the namespace and we're good to go. And so now as an admin, I'm not really creating workloads here. Rather, I'm setting up an environment that allows a developer or DevOps team to go and deploy workloads. So let's flip over to that view and see what that looks like. So now we're over in a shell, and one of the first things I'm going to want to do is log in. So to do that, we have a login command that allows me to see, to connect to my corporate identity and log into the server with that identity. So there we go, we've logged in. And you know, I can navigate around this. It's a regular Kubernetes cluster. You see the different namespaces we have running in this cluster. So let's switch over to that Kubernetes birthday namespace that we just created. Now you'll note that I'm using use context instead of just the namespace command, and that's because in vSphere we can have multiple clusters under a single vCenter. So that namespace that I have access to, those might be actually on different clusters. So we use context, and that'll change both the API endpoint of the control plane as well as the namespace. By the way, vSphere manages your whole kube config file for you. Now, one of the things I talked about earlier is that while we're using Kubernetes, it's kind of a pretty different Kubernetes environment. So to illustrate what that looks like, I'm going to do a kubectl API resources. And this normally shows you like all the different API objects that you can control through kube control. And I'm going to go filter these to look for the ones from VMware. And so what you see in here is a whole bunch of these operators that we've added to the platform. There's things like load balancers, virtual machines, registries, right, and a bunch of other things. And so these are all these operators that VMware has added to Kubernetes in the vSphere 7 product that allows you to control cloud-like resources through a Kubernetes interface. So let's look at one of them. Let's take Tanzu Kubernetes Grid. So if I want to create a Tanzu Kubernetes Grid cluster, I just create a declarative YAML spec for it. So here's a declarative specification for a TKG cluster. You know, it looks like a regular Kubernetes object. You'll see it's the Tanzu Kubernetes cluster is the API kind. It's got a name. And in the minimal configuration of a TKG cluster, we have to specify a topology of how many control plane and worker nodes we have, and a distribution version, which says which version of Kubernetes I want to run. So here we've got this all set up saying I'm going to run one control plane node and one worker node running 1.16.8. So now if I want to create that, I can do a kubectl apply -f. Bam, that's it. That's all I had to do. Now, if we go back over to the vCenter UI and look at what our admin sees, let me flip back over to the hosts and clusters view. It's got a little more details. So we can see now there's that Kubernetes birthday namespace appears in here. And you know, I'm running on a nested virtualization environment here, so things are going to go kind of slow. But luckily, I've set up another namespace so we can dig in and look at one that's already running. So let's flip over to the other namespace. And now inside of here, we can go look at those Kubernetes clusters. So let's do get TKC. So I see I've got a single TKG cluster in this namespace called TKG cluster. I can do a kubectl describe TKC, right? And so now I see the full spec and status of this Tanzu Kubernetes cluster. I can see all the information from my initial specification, like the version number and the topology of control plane and worker nodes. I can see that we're running a Calico CNI, and I can see the CIDR blocks and IP ranges that have been assigned. You know, and we're using cluster API and kubeADM under the covers. So you can see all the add-ons, the cloud provider, CNI, CSI that got loaded into this cluster when it got created. It's pretty neat, right? So, you know, that whole cluster now is really just like an object inside this vSphere Kubernetes cluster. Now, one of the things you might have noticed is that when we created that cluster, if you're paying attention to the topology, it had this thing that was like best effort small, which is, and we call that the class of the worker nodes. And so those are represented in another CRD, another operator in the cluster called a VM class. So if we do a kubectl get VM class, I can see all the VM classes that are defined on this cluster, and control describe best. If I look at one of these classes, I can see this is a declarative Kubernetes YAML spec, but it specifies a hardware specification for a virtual machine. In this case, one with 4 CPUs and 16 gigs of RAM. You know, we also have the best effort extra large, which is 32 gigs of RAM. And so what we've been able to do is expose these core infrastructure as a service concepts through Kubernetes. And so that you can actually use Kubernetes now as a DevOps user to provision and manage workloads on top of vSphere. Now, as we go back to the admin view, this is all super easy for the VI admin to use. This is just the traditional vCenter UI that they're accustomed to. You'll notice that in that whole process of creating that Tanzu Kubernetes grid cluster, as a VI admin, I didn't have to do much. All I really did was set up an environment, a namespace for my developers, gave them permission to access that environment, and then the developer, through the shell and through kube control, is the one that actually created a TKG cluster. They could create a bunch of TKG clusters, or they could create vSphere pods, or they could create load balancers or other objects. As a VI admin, my job is mostly to create the guardrails and the boundaries and to manage that workload that developers created. Now, inside of vSphere, we give all kinds of visibility to the VI admin about what's going on. On this namespace summary view, I can already see things like capacity and usage of, how much stuff is running inside of here. On this monitor view, I can see all the Kubernetes events that are getting aggregated from the underlying namespace, so I can see what's going on inside of there. I can manage the configuration of this, set things like resource limits and object limits if I want to set quotas on a team. I can add new users and decide who has read or edit access to the namespace. And I have all these inventory views where I can see, all of the different individual objects that developers have deployed into this namespace. So it really gives me, as the data center operations team, really deep visibility into these workloads, the Kubernetes, Tanzu Kubernetes cluster workloads, and anything else that developers have deployed into the data center. So that's it for the demo. I think what's really exciting to us in the vSphere team is that Kubernetes is really a magnificent architecture for building a data center. And what we're trying to do is to combine the best of what Kubernetes has to offer with vSphere and really create a new kind of data center platform with Kubernetes driving the DevOps developer experience. At the same time, what we're able to do is to package that in a form that's super easy for the vSphere user base to consume. It's really not much different than consuming any other vSphere environment or a vSphere version that our customers have used in the past. And we're able to deliver a complete enterprise-grade solution without a ton of configuration, a ton of customization, and all those things. You can pretty much just start this up and start using it. So please take a look, download it, try it out yourself. I think you're going to like it. So thanks for your time.
Hello, my name is Erin Munsell. I'm the Director of Product Management at VMware. I want to share with you a little bit of perspective on how organizations are adopting Kubernetes, some of the challenges they typically face, and how we're solving with this pain with a new product called Tanzu Mission Control. So most organizations that are starting to adopt Kubernetes really start pretty small. Oftentimes, this is a single development team within a single line of business, really making the move to containers and Kubernetes. And Kubernetes certainly does take some ramp up time, but at this scale, things tend to be fairly manageable. However, once this adoption journey begins, growth can quickly accelerate. So more teams within an organization start to adopt Kubernetes. And oftentimes this is multiple teams deploying multiple applications onto multiple clusters, also in a variety of environments. So this could include on-prem, public cloud, bare metal, and even at the edge. And there's a challenge with this is there's really not a underlying a mapping between the teams and the applications and the underlying environments. And according to IDC analysts, in the next 5 years, something like 500 million applications using cloud-native tools and technologies like containers and Kubernetes are going to be built. This is equivalent to the total number of applications built over the last 40 years. And so with so many cloud-native apps being built in your organization, you can easily see how this landscape can get even busier in a short period of time. A lot of the customers that we work with at VMware are facing a future of increased fragmentation. So application teams may be running Kubernetes in different clouds. One team might be running on AWS, while another might be running on a cloud provider managed service like EKS or GKE, for instance. And this is a really good thing for these application teams to have choice in where they run their apps. But it also brings a lot of challenges into the operational side. For example, how do we gain visibility into these clusters? How do we ensure that the clusters are secure and configured correctly? And how do we ensure that these resources are being used efficiently? And these challenges are certainly exacerbated when operating across multiple clouds. But even as you grow the number of Kubernetes clusters within a single environment, vSphere 7, as you have seen, really provides powerful capabilities to VI admins to deliver Kubernetes to development teams. But these teams are quickly going to grow the number of Kubernetes clusters that they're going to need to manage and the applications running on those clusters. And these are really the challenges that VMware Tanzu Mission Control seeks to solve. Tanzu Mission Control is a centralized management platform for running Kubernetes clusters and applications across teams. There are a couple of key design principles with Tanzu Mission Control. The first is that we enable you to operate and manage any Tanzu Kubernetes grid cluster from VMware, but also any conformant Kubernetes cluster, allowing you to extend to environments like EKS or OpenShift. Thinking back to some of the origins of Kubernetes itself, Kubernetes really enabled us to stop operating against or thinking about individual nodes and rather operate against a pool of resources. However, a pretty general trend that we've seen within a lot of the organizations that we work with is a growing number of smaller clusters. And so the challenges that we once had, now we're back to operating against a smaller pool of resources. And so Tanzu Mission Control enable us to abstract that pool and really think and operate against a fleet of clusters across environments. The other key design principle for Tanzu Mission Control has really been developer self-service. So we really need to focus on providing the tools for the operations teams to ensure environments are secure and configured correctly. But at the end of the day, we have to provide self-service access to developers so developers can move quickly and focus on applications. So let's jump over to a quick demo so I can show some of these things in action. All right, so I'm going to be driving this demo from the UI, but Tanzu Mission Control is an API-driven system. We also have a CLI. So as a Kubernetes operator, I can see all of the Kubernetes clusters across my organization running across many different environments. We can create Tanzu Kubernetes grid clusters directly from Mission Control across any environment, but we can also attach any Kubernetes cluster running anywhere for not only visibility, but control and management of that cluster. So as an operator providing Kubernetes to development teams, I'd like to create a new cluster to create additional capacity. We can currently create a cluster on AWS, but we'll be adding vSphere as well as other public clouds. This AWS cluster is based on Tanzu Kubernetes Grid, and it's driven from the open source cluster API technology. Tanzu Mission Control provides an easy way to manage clusters, but with more customization than some of the managed services. So the first thing that I'll do is provide this cluster a name, and I'm going to add it to a cluster group. Cluster groups really allow operators to ensure consistency in configuration and the security posture of these clusters. So I'll choose this development cluster group. I can choose some parameters for this cluster, the AWS region, Kubernetes version. I can choose whether I'd like to create a new VPC or leverage an existing VPC. And I also can change some of the networking settings. Next, I can choose whether this is a single node control plane development cluster or a 3-node control plane production cluster. I can also choose the instance type for these control plane nodes as well as the AZ. And then finally, I need to just set some configuration on what I want the node pool or the pool of worker nodes to look like. So I can choose the number of the worker nodes. I can change the instance type. I can also add additional node pools. Now, any of this can obviously be changed in the future as well. And then I would hit create, and that's pretty much the extent of the experience. I'm not going to actually hit create. That cluster would take about 5 to 10 minutes for those AWS EC2 instances to come online and for Kubernetes to be provisioned. So I'm not the only person in my operations team. I want to make sure that the rest of my team has access to this cluster as well. So by making this new cluster part of the development cluster group, my team is automatically going to get access without having to do any additional work. So let's see what this actually looks like. So we can see here in the policies section that I have a number of cluster groups that I've created. Under each of these cluster groups are the clusters that have been assigned to that group. So when I create a new cluster as part of the development cluster group, it's automatically going to inherit those policies without having to do any additional work. So now that I've created these new resources, I want to actually provide access to the development team. So Tanzu Mission Control really takes an application-centric approach. So modern apps tend to run on multiple clusters and oftentimes across multiple clouds for resiliency. And so we can use namespaces to create an isolated deployment environment across clusters running in multiple clouds. And then we can easily apply policies consistently across those clusters, even ones that we've attached from public clouds. So as an operator, I can create a workspace to provide self-service access to development teams. This workspace really provides the team or the application view. So you can see as part of this Acme Fitness application dev and staging instance workspace, I already have a number of namespaces created. As an operator, I could go and create a new namespace directly, but probably what I'd actually want to do is provide the development team self-service access to this workspace where they can create their own namespaces. And those namespaces are going to inherit and apply to any policy that I've set at that higher level. So again, we can kind of see what this looks like within this organization tree. So here's this workspace that I just mentioned. Part of this workspace, I have a number of namespaces that are attached to the workspace. So when I create a policy as an operator to this workspace, these namespaces are automatically going to inherit any of those policies. You can see what I'm showing here in terms of access policies, but we've also built out image registry policies to specify or whitelist which registry images can be pulled from, a network policy to specify the ingress roles into these namespaces, as well as security policies. So this workspace is really currently about policy management, but we see this as a really powerful way to connect the dots to deployment systems, enabling consistent deployment of applications, whether these are modern apps written to run on Kubernetes or off-the-shelf apps as part of the Tanzu application catalog. So lastly, as an operator, I'm responsible for the health of clusters across the organization. So I can view the health of these different clusters and quickly dig into any issues. So let's look at one of these clusters and check out what we can see here. So we see some information on the metadata, overall CPU and allocated memory for the cluster, as well as the health of the Kubernetes components, the health of the Kubernetes worker nodes. We can dig in to quite a bit more information, including digging into the individual nodes. And then for each of the nodes, we can even go one level further and see some information on the node conditions and the pods that are running on that node. We're providing some pretty high-level health information here, but we're really focused on integrating with industry-leading monitoring and observability tools. And one of those is VMware's Tanzu Observability by Wavefront. So in summary, Tanzu Mission Control allows us to manage not only Tanzu Kubernetes grid clusters on vSphere 7 as well as other environments, but really any Kubernetes cluster across any environment. So we take out a lot of the error-prone and manual work that exists without something like Mission Control. So imagine the power of something like Tanzu Mission Control to enforce consistency across thousands of retail stores or shared Kubernetes clusters that are being accessed by tens of thousands of developers. Thank you.
Hi everybody, my name is Bosky Savla and I'm a technical marketing manager working on modern applications at VMware. Today I'm going to talk about how VMware is helping simplify the Kubernetes user experience based on Tanzu Application Service for Kubernetes. Now, if you think about a life a little bit, go back in history and think about how applications were built and deployed before Kubernetes came along. Essentially, you'll see a degree or variation of something like this, right? There's a development team that is working on creating that application, coding it, etc. And then there's a team that is actually trying to figure out how to push that application to a given infrastructure. Now, sometimes these processes could be very manual, wherein every step is manual, and you're trying to somebody's actually physically sitting there clicking virtual machines, deploying, integrating with load balancers and things like that. And at times we also start seeing organizations do this with some configuration management tools like maybe Chef, writing Chef recipes or Puppet manifest files or Ansible, etc. Now, with a completely automated system where a configuration management system is going to automate the deployment and the maintenance of that application, even while doing so, apart from writing the application code itself, a team now has to start deploying or working on coding this configuration management tool. And a lot of times these config management tools have a one-on-one mapping to a particular infrastructure. So if you write a chef recipe for AWS, it may not work on Azure or vice versa, or it may not work on vSphere. And hence, like, you'll have to, portability also is not that, easy. Plus, developers don't necessarily see where their application is being pushed. It's always there's this manual wall where things have to be pushed to a particular team to get it done. I think Kubernetes changed a lot of this paradigm by abstracting away infrastructure. We all know that Kubernetes does this very well. Now, Kubernetes is abstracting away infrastructure, so it's making things a lot more simpler. So rather than having to talk to every infrastructure provider that you may have, for example, talking to AWS, talking to vSphere, talking to Google Cloud, Azure, you now just talk to the Kubernetes API, and then the Kubernetes API is going to handle a lot of the workload creation and deployment workloads on that particular infrastructure. So this simplified a lot of things in terms of how applications get deployed and maintained. Now, another thing that Kubernetes is doing pretty good is it is a lot more application aware than a lot of these tools and systems. So for example, every application has specific needs, like every application or a workload needs to be deployed, it needs to be scalable, it needs to have load balancing, it needs to have ingress, it needs to have a way to, manage configuration elements at runtime, etc. And so Kubernetes, if you think about it, has a resource object defined for each of these of this particular application needs. So it has pods, deployments, replica sets, services, ingress, etc. to take care of that particular application. And this is where the power comes in, right? Where the wall is broken and application teams are now, the development teams themselves can define very simply what the end state of that workload needs to be and push it to a Kubernetes API, and the API or the Kubernetes cluster in the backend works with your infrastructure provider to make all of this magic happen. And I feel like this is really the crux of why Kubernetes is so popular, the way it works for developers and the way it really abstracts infrastructure. Now, let's take a look at what that developer experience feels like, for example, to deploy a simple 2-tier or 3-tier application, which has a need to deploy persistent storage and hence some runtime configurations to manage. Now, typically, I would, as a developer, one would start building or writing that code. They would then create a Docker file and containerize it, build a container, push it into a registry. And then finally, before pushing it to Kubernetes or giving it to Kubernetes, the team will have to define what kind of Kubernetes objects are needed to run that particular application. So some of the common objects would be, you need a deployment type, maybe you need a replica set, maybe you need a service. So these are some of the common elements that need to be created. But then if you're talking to a database server, for example, then you'll need to define, a way to talk to the database server. So you'll probably end up using secrets or config maps to do so. So the dev team then has to define a lot of these manifest files that are needed for that application to effectively run. And that is just for the, a single tier of that app. Similarly, for every other service or, for example, a persistent storage that the application needs, you'll have to go ahead and do the same. You'll have to define secrets, you'll have to define deployment, persistent, volume, etc. And all of this for a 2-tier app may feel like a little bit of an overhead in terms of your overall development life cycle. And we definitely feel that we can make this process a lot more efficient. I mean, Kubernetes is already making things so simple for dev teams where they don't have to think about what is an AWS load balancer versus what is a vSphere load balancer, etc. But then we feel like there is a scope to redefine the experience of even talking to the Kubernetes API. And that is where we are working to create this new integration where we understand that Cloud Foundry, which is a PaaS or platform as a service, is very popular with development teams because of the simple user experience that it gives developers. As in, you can simply write your code, do a CF push, and then Cloud Foundry completely takes over and maintains your application for you without you having to, understand much on how it's done. So what we are doing is we are taking elements, or what we thought we'll do is Kubernetes has so much to offer, and the developer experience of Cloud Foundry is amazing and people love that experience. Why don't we integrate the two together to make this even more rock solid of a solution? And that's what we did with Tanzu Application Service for Kubernetes. What Tanzu Application Service for Kubernetes does is it gives you that familiar CF push experience, at the same time the abstraction and the capabilities that Kubernetes brings. Essentially what we are doing is we are basically integrating or re-architecting Cloud Foundry runtime components to be running as pods and containers within Kubernetes. And I'm not going to get into the architecture a lot because it's a very in-depth, it might take an hour, but let's say you do a CF push of an application workload, with one that you have already coded. Once you do a CF push, what effectively happens is the CF runtime components that are running on that cluster, for example, the build service in particularly, is going to take all the files needed for that application workload, create a Docker file, run a Docker build on that, and create an image, and it will then push that image to a registry of your choice, a container registry. Once it has done that, it will start talking to the Kubernetes API to deploy that application into deployment and pods, and then finally it will also create services and ingress for that specific application. So effectively, a single CF push command in turn is going to talk to Kubernetes and do multiple different tasks that a dev team would have done anyways. Let's take a quick demo of how this works. So here's my Kubernetes cluster. I'm running this on Tanzu Kubernetes Grid. And this Kubernetes cluster also has the Cloud Foundry for Kubernetes components pre-installed. So if you look at the namespaces, it will have like the build service, some of the namespaces that are needed for Cloud Foundry to operate on Kubernetes. And you'll see some components, like you'll see this CAPI API server, the KPAC, the build service, etc. running. These pods that are running on the Kubernetes cluster are essentially going to help us deploy an app. So the Cloud Foundry runtime is essentially running as an application within this Kubernetes cluster. Now let's take a look at a specific namespace called CF workloads. Now within the CF workloads, you'll see that this is where a lot of the applications that we'll be pushing into this cluster will get deployed. We also have Istio running on this cluster, which will help, which Cloud Foundry uses to build ingress routes. So let's jump in and start deploying an application and see what the experience looks like. So I have a very sample Go based application that's just going to show me the index at a given point in time. And I'm already logged in to Cloud Foundry that is running on the Kubernetes cluster over here. So as you can see, if I do my list of applications, there are no apps currently running. And my goal is to push this Go-based application into Cloud Foundry. So what I'm going to do is I'm just going to get into that directory where my application sits. So I'm calling it a test app. Here are all the files for that application. And I'm just simply going to do a CF push. And I'm going to give it a specific application name or an ingress route. So I'm going to call it test app. So in the backend, if we go back to the cluster, you'll start seeing that the CF workload staging area starts building up. You'll start seeing some workloads getting created over here. And the build service is going to basically take the application files, push them in a Docker file, and upload it to my registry. In my case, I'm going to use Docker Hub as my system registry, and you'll, in a bit, you'll start to see that on my Docker Hub, this new container image will be published. So it takes a little, maybe a minute or two to finish this setup. Okay, so let's take a look at the applications. You'll see that the test app has been pushed into the cluster. Let's take a look at the cluster itself. So if I go to my namespaces, if I go to CF workloads, you'll see the test app pod getting created. You'll also see some of the stateful sets needed for that application to run. You'll also see the services that were built as part of that application, and an ingress and a network policy. All of this happened without us telling Kubernetes what to do. It created the defaults needed to effectively run this application on the Kubernetes cluster. If I go back to my Docker Hub and just refresh this page, you'll see that this particular image that I just, the Cloud Foundry running on that Kubernetes cluster actually pushed this image into my Docker Hub 2 minutes ago without me having to build any Docker files or create any, or build any images. All of this was automated within the Cloud Foundry instance. Let's take a look at the application itself. So you'll see this is a simple app that's running with an ingress root running on that particular cluster. So this is a very simple example of how a CF push is going to help us build all these different Kubernetes components needed to effectively run that application. Apart from just pushing application, running the container images, building it, deploying services, etc., Cloud Foundry is also going to help us manage logging systems. So if I need to see the logs for that particular pod or container, I simply do CF logs for my app, and we are going to start seeing the pod logs running in our terminal. Similarly, scaling that application is also pretty simple. I can simply say CF scale, and my instance count is going to be 2. Sorry, I forgot to give it the name of the app. And if we go back to our, what this is going to do is basically create another pod for that particular, it's going to pull the image from my Docker Hub and create a new pod. So if we go back to workloads, you'll now see that there are 2 pods running because we just scaled it using CF scale. So this is just a few examples how utilizing the CF push or the CF API, we are essentially wrapping multiple Kubernetes APIs behind a single CF API to run our application and effectively simplifying the developer experience. Thank you.